Manage to relate to the this is like
Okay, guys, it's nice having you again. You came back for some more. Here are the objectives. We will describe when a solution of a salt is acidic or basic. We will demonstrate with equations how buffers resist change in pH. Key term you should be able to describe in your own words: a buffer, equilibrium. You should already know what equilibrium is, and you are going to describe what is a salt in your own words, what a salt is. Now, let's talk about salt. What is a salt? A salt is an ionic compound. Ionic compound. Now, let's describe it a little bit more. If I have, let's take for example, HCl, which is a strong acid, react with NaOH, which is a strong base. It will produce, this is not equilibrium, it is a neutralization equation. We said last class the hydrogen from the acid will react with the hydroxide from the base to produce your water, and the cation from the base will react with the anion from the acid to produce your salt. So we can give another description for a salt. A salt is an ionic compound which cation comes from a base and the anion is from an acid. I am going to describe for you what is a neutral salt, what is a basic salt, and what is an acidic salt. Not all salts are neutral. Not all salts are neutral. It is extremely important. Okay, we are going to describe an acidic salt, a neutral salt, and a basic salt. Listen carefully. If the cation is from a strong base and the anion is from a strong acid, your salt is neutral. Okay, if the cation from the salt is from a strong base, the anion from a strong acid, you have a neutral salt. When do we have an acidic salt? Okay, so if the cation, let me give you an example. An acidic salt, let's go with ammonium chloride. Ammonium chloride. Let me write my salt right here. Let me reset. And I'm going to write ammonium chloride. This is a salt. It is an ionic compound. It is made of a cation and an anion. Now, that cation came from NH3, which is a weak base. Plus, this anion comes from a strong acid. Let me change my pen here. This is a strong acid. Let me change this here. I'm going to write a weak base. That salt is acidic, so strong winds. Okay, the anion from the salt comes from a strong acid. The cation comes from a weak base. Therefore, that salt is acidic. This is an acidic salt. Okay? So let's go with sodium acetate. Sodium acetate. This is my salt. This is sodium acetate is C2H3O2. This is a salt. It is an ionic compound. Let's see what base gave that cation. It is NaOH. Plus what acid gave that anion? It is acetic acid, HC2H3O2. So change the color here to help you a little bit. Sodium hydroxide is a strong base. Acetic acid is a weak acid. So strong wins. Therefore, that salt is basic. Okay, so I just gave you an example for a neutral salt, an acidic salt, and a basic salt. Now, let me show you exactly how you can prove that salt is acidic or basic. This was a quick and dirty way I showed you to know. But this is not an explanation why the salt is acidic or basic. Here is the explanation. Let's write down sodium acetate. It is NaC2H3O2. This is a salt. It is soluble. When you put it in water, it will dissociate completely into Na plus and C2H3O2 minus. Okay, you put that soluble salt in water, it will dissociate completely. Now, if I take my C2H3O2 minus, it is in water. Let me show you what will happen. Did we say sodium acetate is basic or acidic? It is basic. We said if we say it is basic, it has to produce OH minus. Has to produce OH minus. Okay, where is that OH minus coming from? It is coming from the water. If you want to make things easier, we can write water as HOH. That OH is coming from the water, and we have an H left that we add to that acetate to produce HC2H3O2. The explanation you give to show that salt is basic is to write that hydrolysis equation. Hydrolysis means breaking water, splitting water. So you take that water, you split it, and then you show it is basic because you just form hydroxide. This is the explanation why that salt is basic, because you produce hydroxide in water. Okay, let me give you an explanation why. Let me show you why ammonium chloride, we said it is acidic. Let's prove it. Ammonium chloride is NH4Cl. It is a salt. It is completely soluble in water, so it will produce NH4 plus Cl minus. Now, that NH4 plus water, I can write HOH for water. That's okay, to make it easier for you to see what's going on. I will write HOH, which is water, H2O. Okay, equilibrium. Now, if we say that salt is acidic, we have to produce H plus. Okay, that's what makes it acidic. We produce H plus. If we use that H plus, that OH minus will go with the ammonium to produce NH4OH. Okay, that salt is acidic because it produces H plus in water solution. So this is salt hydrolysis. Hydro, water, lysis, splitting. When those ions react with water, if they produce hydroxide ion, the salt is basic. If it produces hydrogen ion, it is acidic. All right, so this is the second part of that section, a buffer. A buffer is a solution that resists a change in pH. A buffer is a solution that resists a change in pH. Even if there is a change, it will be a very, very small change in that pH. Okay? I'm going to show you exactly how a buffer works. And I will tell you, if it were not for buffer, you would not be here. If you don't have buffer in your body, you would die. Why? Because your blood has to be at a pH of 7.4. So if you eat something very acidic, the pH would go down, you would go into a coma and die. If you eat something very basic, that pH would go up, you would go into a coma and die. Okay? So the only reason why you're still here living, that's because you have buffer in your body that will make sure when you eat that lemon with a low pH, the buffer will be ready to attack it and keep your blood at a pH or around 7.4. Okay? So that's why when you go to the doctor, they take a urine sample, take your blood to check the pH, all of this. So let me show you exactly how a buffer works. A buffer is made of two components. A buffer is made of a weak acid and its conjugate base. I hope you remember what is a conjugate acid base pair. Let me repeat. A buffer is made of a weak acid and its conjugate base, or of a weak base and its conjugate acid. Let me give you an example. This is acetic acid. Its conjugate is acetate. We said the only difference between an acid and its conjugate base is just a hydrogen ion. The acid will have an extra hydrogen than its conjugate base. So it's like they are partners. So a buffer will have those two partners, a weak acid and its conjugate base, or a weak base and its conjugate acid. What happened? Let's say you have those two partners. Don't write partners on your test for me, please. It's not a chemical term. Okay, you can think about it, but don't write it. So if we have those two partners, that acid and its conjugate base, same amount. Let's say you come and eat something very acidic. The basic part of that buffer will be ready to react with that hydrogen ion to produce the acetic acid back. That's why you have a higher level of that acetic acid than you had of that acetate, because some of the acetate will react with the hydrogen ion to produce acetic acid, and the acetate level went down because you use it up. So that partner will react with your hydrogen ion. So if you eat something very basic that produce OH minus in your blood, that partner, the acidic part will react with the OH minus to produce the acetate and to produce the acetate. Okay, that means you are using up that OH minus. You are using up. It doesn't matter what you eat, acidic or basic, one of those two partners will be ready to react with it. Okay, so you won't have a high level of hydrogen ion or a high level of hydroxide, because those are the ions that will determine the acidity or the alkalinity of the solution. The hydrogen ion or hydronium ion, the hydroxide ion, those are the ones that will determine if the solution is acidic or basic. So when you have those two partners, they will be ready to react with either the H plus or the OH minus. Like your pancreas in your body will produce bicarbonate HCO3 2 minus, HCO3 minus. Okay? If you get something very acidic, that HCO3 minus will react with that H plus Okay, in your kidney, the kidney will take part, it will take care of this, react with the H plus to produce H2CO3, which will decompose into water, and guess what, you produce carbon dioxide gas in your kidney. So the bicarbonate produced by your pancreas will take care of the excess acid in your blood. Show how the carbonic acid hydrogen carbonate buffer can mop added hydrogen ion and hydroxide ion. I think I pretty much covered this already. So those are the two partners. Carbonic acid is H2CO3, and then the partner, its conjugate, that's what you should use, the term you use is HC2HCO3 minus. So this is the acidic part, this is the acid, and this is the conjugate base. So if you eat something that is basic, so the OH minus will react with the carbonic acid to produce water and HCO3 minus. If you eat something, this is the base part, if you eat something that is acidic, I already said that acid will produce H plus, which will react with your HCO3 minus to produce H2CO3, which will decompose into water and carbon dioxide. So this is a buffer. This is how a buffer works. You have other buffers in your body. There are many proteins in your body that would not be able to do their jobs if your blood pH is not at 7.4. So because of buffers, you can function. Those proteins can do what they are supposed to do. I hope this helped. If you have any questions, bring them to class.